So the next topic that we are going to discuss is called as the binomial theorem. The binomial theorem. So in algebra, we know that there are a lot of expressions that we can write. Out of those algebraic expressions, which consist of two dissimilar terms. Okay, so the terms containing two dissimilar, uh, the expressions containing two dissimilar terms are what we are going to call as the binomial expressions. So how to expand them, we'll see by using what is called as a binomial theorem. So before looking at the theorem, let's see what is an expression which is binomial expression. So an algebraic expression which consists of the condition is that there should be at least, right? So two terms or two dissimilar terms. The two dissimilar terms with you can have positive or the negative sign between them. So such term is called as a binomial called as a binomial expression. Right. Now let's try to write an example. So you see, it's simply x plus a. This is one binomial expression. There are two terms plus or minus sign between them, right? So another example like x squared into a minus a by x. Another example. Okay, so p by x to the 4 minus q by x to the 5 is another example. Okay, and so on, right? So normally, a algebraic expression consists of three dissimilar terms is normally called as a trinomial concept, right? So trinomial expression, you can have four terms, five terms, and so on. But out of all those two terms, the one which consists of two terms is of highest significance for us. There is a lot of significance for that particular uh, this thing. So hence we use what you call as the binomial is right studied specifically. Okay, all right. Let's move further. Now let's try to write what is the theorem. So I'm writing the theorem's statement now. So the statement goes like this: if x comma a belong to C and the n belongs to the capital N natural numbers, then if at all you have a x plus a raised to the power n, right? This can be written, this can be expanded using the following format, that is mc0 x to the power n minus 0 into a to the 0 plus nc1 x to the n minus 1 a to the 1 plus nc2 x to the n minus 2 a to the 2 and so on. Like that we can write the last term somewhere in the middle. Okay, let's write a nth term. This is ncr x to the n minus r into a to the r plus. So like that we can write our last term. Let's like nc n minus 1 into x to the 1 a to the, this is n minus 1, and let's write the last term. So this is actually the n minus 1th term, and the last term will be ncn x to the n minus n, so this has to be 0. Yeah, so this is 0, x to the 0, and a to the n. So this is how you try to expand. In short, you can give a short form of this. This is the summation for r varying from 0 till the value n. This is ncr a to the n, not n, sorry, this is x to the, because we are writing x first. So into x to the n minus r into a to the r, right? Here, this particular ncr is, right, nc naught, nc1, nc2, nc3 up to ncn, they are called as the binomial coefficients. It's binomial coefficient. Okay, now, so let's write a quick note about this. All right, now, so the note about this point is, now here in this particular expansion, each term, the degree is n, and the coefficient of x to the n minus r a to the r is equal to the number of ways in which we try to represent uh, right, x and a, right, in different formats. That's what that's why we have written nc1, nc2, nc3, etc., right? So okay, now, so that's what is the first point to remember. In each of the terms, the degree of each term is nothing but the n. Okay, and the coefficient of x to the power n minus r into a to the r, right, is the ncr. Right, what is ncr? We can actually expand this. This is nothing but the n factorial divided by r factorial into n minus r factorial. Already we know this, we can definitely calculate this, right? Any coefficient I want to find, I can, right? And let me try to write another equation now. This is also very useful, right? So if let's say the expansion is x plus a to the n, and anyway we know that this can be expanded as r is equal to 0 to n ncr into x to the n minus r a to the. So if I try to replace n by n minus r, because ncr is ncn minus r, it should not change. That's what I'm expecting. So let's try to see this. So replacing r by n minus r, right? We'll try to find out what exactly this is going to give. So the s is, which is equal to x plus a to the n, can actually be expanded in a very similar fashion, that is summation r is equal to 0 till n. So this is nc, r is a n minus r. Okay, so x to the power n minus, right? I had a power r, which is now I have to write every r as n minus r. So x to the power n minus r into a to the power, I had r, so this becomes n minus r. All right, so this can be equivalently written as r is equal to 0 to n. This is nc n minus r x to the r, because n and minus n cancels, minus of minus r is plus r, x to the r, a to the n minus r, right? So this means you are simply rewriting the binomial, what you call expression in the reversing order, reversed order. That's so this implies n into n minus r means, right? By replacing n by n minus r, we are uh, writing the binomial expansion in the reverse order, because every term becomes, you see, x of x to the n minus r becomes x to the r, a to the r becomes a to the n minus r. That's what is the indication of reverse. Okay, so that's the point number 2. Then let's move on to the next one, right? So what happens if I replace a in the expansion by minus a? So this gives us the expansion for x minus a to the n, right? So very simple now. This is nc. Let me expand for the first few terms. Nc naught into x to the n minus 0, right? It is a to the 0. Anyway, it's actually minus a to the 0. Okay. Uh, right. Initial first term will be positive because irrespective of what is minus a, it's power 0, a to the 0. But next term is negative because a is minus. So this is nc1 x to the power n minus 1 into a to the 1. See, a to the power 1, a is negative, so that's the negative sign which we are writing here. Okay, whenever a to the powers become odd, there is a minus sign, otherwise it is plus. Now you see it's a square, so it's a positive, doesn't matter. So you can simply write nc2 x to the n minus 2 into a square. So a is negative, a square is positive. So I understood what exactly is happening here. Whenever a's power is uh, positive and it's a even number, no problem. It's a positive sign. The term is positive. Otherwise, the term is negative. Okay, so that's what is the idea now. So let us try to expand this further and write the nth term, sorry, rth term. Somewhere in the middle, I'm going to get the rth term. So that term, I can write it as, I don't know whether r is positive or negative. So I'll just write minus 1 to the r. Because if the power is an even number, minus 1 to the power even number is a positive. That's why. So minus 1 will take care of it. All right. So minus 1 to the r into this is ncr x to the power n minus r into a to the r. So that's the rth term and so on. We can write the nth term as well in the same way. So again, minus 1 to the n, depends on what n value, positive or negative, into ncn. This is x to the powers are reducing, so it reaches 0. A to the power increases and it reaches n. Okay, so in general, I can rewrite this equation as this. This could be the summation r is equal to 0 till n. I just have to add in minus 1 to the power r here. Rest remains same. ncr x to the n minus r into a to the r. So find the fourth term, find the sixth term, etc. We can definitely find using these kind of concepts. Okay, all right. Now, uh, let us try to do another math calculation here. This is the fourth one. So let me assume that I want to calculate, I want to add the terms like this. I know what is x plus a to the n, and I want to perform plus, this is x minus a to the n. What happens if I add both of them? So you see that some of the terms will cancel. The odd indexed terms will cancel. Okay, even indexed, fine. Odd indexed, right? They are present in both the terms. They should get cancelled. So because of that, I'm going to get even index terms are getting twice. So 2 times 2 into, you see this term nc0 x to the power n minus 0 a to the 0 plus the even, so nc2 x to the n minus 2 a squared and so on, right? So you get all the terms like this. I don't know what is the last term, so I don't know. So the point here is that this is 2 times, right? The sum of the terms at, right? You see the first position, this is, this number is there, this is there, right? And so on. So they are odd indexed terms. They're positioned at odd places. Okay. So sum of the terms at odd places. Right. So 2 times this is the answer when you add the two terms. At the same time, let me subtract. So that means x plus a to the n minus of x minus a to the n, right? This means you get the even placed term. So what you get, this is 2 times, you see, nc1 x to the n minus 1 a to the 1 plus nc3 x to the n minus 3 a to the 3 and so. Again, I don't know what's the last term in this case, how many n's you may have, right? So you just leave this. This is easy to understand. So this is equal to, now I can write this is 2 times sum of the terms at even places. So let's move further. So using these concepts, we can directly rewrite some of the very standard terms. So the standard terms are something like this, right? This is point number 5. I think 5 or 6. 6. Right. So if x equal to 1 and a becomes equal to x, right? If this is one very standard term, so it becomes 1 plus x to the power n, right? 1 plus x to the n. So wherever you see x, right, this, okay, let me try to write the expansion. This is nc0 into x to the 0 plus this is nc1 x to the power 1. You see this, the since the x is equal to 1 here, right? The term, right, 1 to the power, it doesn't matter. So plus nc2 x squared, right? And the last term is ncn x to the power n. So I can try to write this expansion in short as, so 1 plus x to the power n is nothing but it's a summation r is equal to 0 till n ncr into x to the power r. So that's the answer. All right. So similarly, we can try to write another one. This is the seventh one. So I try to write, right. Okay, I don't want to write what I'm trying to do. I'll directly write the expression itself. This is easy. Right. So I want to find 1 minus x to the n. Okay, so this is nc0 x to the 0. You see the next term becomes negative, right? Because of the minus x over. So this is nc1 x to the power 1 plus nc2 x to the power 2. Next number becomes negative, and after that the next term will be positive and so on. So this is minus dot 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 dot, right? Plus, alternately minus and plus. Let's write the nth rth term now. So minus 1 to the r. This is ncr into x to the r plus, try to write the last term. So this is plus minus 1 to the r, minus 1 to the n because I'm writing the nth term. So minus 1 to the n, this is ncn into x to the n. All right, so this means what we are trying to write now is this. This is equal to summation, say r equal to 0 to n minus 1 to the r n c r into x to the r. All right, this is 1 minus x to the n. One's very standard result. Okay, now let's solve some of the fundamental problems related to the binomial theorem and the binomial expansion. So the problem number one is expand the following using the binomial theorem. So the term is this 2a minus 3 by b raised to the power 5. So I can see that in this case, right, I can compare. This means, right, I have x plus a, so x equal to 2a, okay, and the a term which we had earlier is now 3 by b, and n is equal to 5. Okay, so this means let's try to expand now using the same rule. It's nc0. nc0 is n is 5, so this has to be 5c0. Until we get practice, we should write this. Okay, so this is 5c0. First term raised to the power n minus 0. So first term is 2a to the power 5, right, into this is minus of 3 by b to the power 0, all right, plus the next term 5c1 2a to the power 4 minus of 3 by b raised to the power 1, then plus 5c2, this is 2a raised to the power 3 minus 3 by b raised to the power 2 plus 5c3 2a to the power 4, okay, and sorry, this is 4 3 2. My mistake. This has to reduce, so this power is 2 into this is minus of 3 by b raised to the power, so 1 2 3. This keeps on increasing, other one keeps reducing. Okay, so that's then the last term we can write. So this plus yeah, plus 5c4 5c4, first term, that is 2a raised to the power 1 and minus of 3 by b to the power 4, and the last term should be 5c5 2a to the power 0 into minus 3 by b to the power 5. Okay, so now let us try to simplify. So 5 6 0 is 1, 2a power 5 is 2 to the 5 is, I think, 32, a to the 5 minus the 3 by b to the 0, you don't have. Then this is going to be negative. Let's simplify. 5c1 is 5 into 2 to the 4 into 3. So this is 240 a to the power 4 divided by b. All right, next number 5c2 into 2 cube into 3 squared. So that is plus 720 a cube divided by b squared. Next number 5c3 into 2 squared into minus 3 cube. So this is minus 1080 a squared divided by, this is b cube. Next 5c4 into 2 into minus 3 to the power 4. So that is plus 810 a divided by b to the 4. Last term 5c5 into minus 3 to the 5. So this is minus 243 divided by b to the 5. This is the required expansion. All right, let's move further. Next question is expand the following. 4x minus 3 by x to the power 7 using the binomial theorem. So first we'll write the expansion. Okay, so this is equal to n is equal to 7, so this has to be 7c0. First term, that is 4x raised to the power 7. Second term, that is minus 3 by x raised to the power 0. So first term keeps on decreasing, second term keeps on increasing as I move, okay, to the next term, right? So that is, this is plus 7c1 first term, that is 4x raised to the power 6 minus 3 by x raised to the power 1. Next term, that is 7c2 into 4x to the power 5 minus 3 by x raised to the power 2. So the sum should be 7 always. 6 plus 1, 5 plus 2, 7 plus 0, and so you can see that pattern will repeat. Alright, so sum should be 1. Next number, plus 7c3. So this is into 4x to the power 765, so this has to be 4, and the next number, that is minus 3 by x, should be raised to the power 3. 4 plus 3, so 7. Okay, then plus 7c4 into, this is 4x raised to the power 3 into minus 3 by x raised to the power 3 plus 4. Okay, so that's why it is 4. Next number, 7c5, 4x raised to the power 2 minus 3 by x raised to the power 5 plus 7c6 into, this is 4x to the power 1 and minus 3 by x to the power 6, and the last term, that is 7c7, 4x to the power 0 minus 3 by x to the power 7. Okay, so expansion is straightforward. So this is equal to 16,384 times x to the 7 minus 86,016 divided by x plus x to the 6 by x, so x to the 5 also. See, there is a x to the power 6, right? Divided by x. So x to the, divided by x into x to the 6 is it? So it becomes x to the 5, correct? Okay. So this is multiplied by x to the 5. Oh, next, plus 1290 24 x to the power 5 divided by x to the power 2, right? X to the 5 divided by x to the 2 is x to the 3. Okay, so this is x cube. Okay, next is negative. Okay, minus 16,128 into x. Yes, then plus 1 2 double 4 1 6 x to the minus 1, or you can write divided by x. Correct. Then minus 1360 80 divided by x cube plus 1 double 2 4 7 2 no, minus 5. So divide by x to the 5. Okay, 1 2 3 4 5 6 ಇನ್ನೊಂದು ಆಗ್ಬೇಕಲ್ಲ. Okay, minus 1 0 7 1 6 3 minus 7. So divide by x to the 7. Okay, so this is the expansion of the given. Okay, how much problem? Solve or simplify the term x plus the root of x squared plus 1 to the power 6 plus x minus root of x squared plus 1 to the power 6. So hint to solve this, consider this as x plus a, right? X plus a to the n plus x minus a to the power n, right? You can use that formula to simplify this. This is an easier problem if you do that approach. Anyway, it's not compulsory. You can even do it using the normal method.